Good evening. There is something you haven't seen for a while. Let's build a PC. Deja vu? Deja vu. But before we do that, there's something I have to address, because many people have suggested that I should not have this microphone on the table because of whatever. So I should have it on suspension or something, so I should probably do that first. So let's do that. And that's it. Is that better? I honestly can't tell, because there are these springs that can generate a lot of noise, so that may not be the best solution, but that's what you people wanted, so that's what we are going to do with. And let's move on. So besides the power source, we are of course going to need the motherboard. So the motherboard is this one. And by the way, before we go forward with this, you guys probably want to know what's going on with the previous motherboard, this one that had the problem with the socket, and the answer is absolutely nothing. I haven't done anything with this after I made the video, because honestly I was prepared to count it as a loss, and that's probably what I'm going to do, because honestly I don't see any way to go forward with it. So this is an ASRock X399 motherboard, and so let's open the CPU socket first. So open 3, 2, 1. 3 is here, 2 is here. Actually this should be just lightly tightened, because I didn't really tighten it that tight. So let's open this. Pull this out. So this is what it looks like on this CPU socket that actually is proper and works. I don't know if the focus is right for this shot, but anyway, that's the socket. So I'm going to insert this Ryzen ThreadRipper processor in there, so it goes into this sled again, like so. So it's there. Just push it down so it locks in the place. It's now locked in place. So close this lid. So 1 until it clicks. There. And then number 2, which is number 2 is here. Same procedure. 2 and then 3. And by the way, some of you may have noticed there's some humming on the background. It's a fan sound. That's because I have studio lights here, and the lights do have some fans on them, so that's what the sound is. I could try to eliminate it in post-process, but it would also degrade my sound, my voice a little bit, so I'm not going to do that. So the next thing, thermal paste. This is Noctua NTH1, and which one is more used? This is a little bit more used. So here's what I'm going to do. And by the way, many people commented on my previous video saying I'm an idiot for doing the thermal paste application like this, in these little dots. So listen, I have been assembling my own pieces for like 30 years, or at least 25 years, and I do know what I'm doing, but sometimes what I do doesn't really match what you have come to expect and what you think is the right way. Listen, if you watch some video on the internet and you see something that is different from what I do, don't just assume that what you see on the internet in the different video is the only possible way to do things, because in the internet there's a lot of cargo cult going on. And actually, if this is the thermal paste application here, specifically what you are interested in, look, this is the manufacturer of this thermal paste is Noctua, and this is a SP3 TR4 socket. Who is the authority on how to apply this thermal paste? I would say it's probably Noctua. So have a look at this video and then come back to comment that they are idiots and they don't know anything what they are doing. So the next part is installing these screws where the cooler goes in, and then on top of those screws goes this cooler block, and this is the water cooling block. And let's verify that it is clean on this side. Verify that this surface is clean. It's not perfect, but it will have to do, because you could get it cleaner by using some chemicals, but I haven't actually looked up those chemicals, and I don't accidentally want to do something that is actually corrosive, so that's how I play. So that's attached now, and then tighten it up. Actually, I could probably already plug this in. This is the cable for the water pump. Water pump cable is there. So next, tighten the cooler up. And the cooler is now tightened up. Now the next thing is memory. Now again, a lot of people called me an idiot because I supposedly installed the memory in the wrong order. This is the B2 slot. Let's put the memory stick in the right way there, and let's push it in. And again, a lot of people called me an idiot for doing things in this way. Some said that I'm an idiot for putting just one memory stick here. Some they said that I should have put it here or in some other slot, and I was an idiot for doing that. Well, here's the thing. The previous video was a demonstration. I did the minimal things to get the thing running because I wanted to show how the motherboard works, because that was the topic of my video. It wasn't my full desktop build. This is actually my full desktop build. And the second thing is, the guys who complained that I put it in the wrong slot are actually wrong. It is exactly where the motherboard manufacturer recommended to put the memory stick if there's just one memory stick. But here's the thing, I don't actually have just one memory stick, I have two. I mean 3. By 3 I mean 4. And that should probably do by now. So these sign slots B2, A2, B2, C2 and D2. And this is the computer case that I'm going to use for this computer. But first things first, let's do something that people in the internet seem to really enjoy doing. I don't know why, but people really seem to enjoy seeing this done. That's that. And inside this case, if we open these two screws here, we can see stuff, and we can probably see that even better if we take the motherboard and the cooler outside the view for a little moment. So move them and then open this case like so. And inside here we find a box of supplies, Fantex accessory box, which contains a manual and attention about RMA requests, and the case of all kinds of screws and whatever this is. see what this is. This is some kind of a bracket. I don't actually know what this is, but probably the manual will tell. And inside here we have a... Actually, I should probably show the back side of this as well. So the back side. Behind here we have a screw that opens from here and another down here. And this case just goes away like this. And here inside this we have a little space for all the wirings, and also these are the slots for the hard drives. And you can probably, yeah, you can just pull these away like this and then just insert. Really cool and really easy to use, I believe. I will be using those. So first things first. Here are some brackets onto which I can put the motherboard. So here is the motherboard. And the massive cooler thing. So let's just initially carefully put the motherboard down there. Also, this bracket is good to put here and now. I have to... So first insert that bracket there and then put the motherboard in place. And that's done. So next I can put the screws in. I'm sorry that you are not getting as good view as you should be getting, because it is kinda difficult to find good camera angles, especially when you don't have a crane to put the camera on. I only have a tripod, so the tripod has to be standing outside the table, so the camera has to be angled somehow, and that doesn't give you perfect shots. It would help a bit if my screwdriver were magnetic, but it doesn't seem to be magnetic, so that is awkward. Also, that hole is not for screws, so let's take it out. Next, place this cooler where it should go. So it should go on top there. Okay, after reading the manual for a bit, I figured it out, because I had to remove this upper panel from here and also from the front. So now I can get access to this. So let's use these long screws. How do I do that? The next problem is I need to figure out what to do with this cable, because this is a computer case that is designed for cable management, so I need to figure out how to do this. I probably want to attach it over there, so let's see. Push it in there, like so, and then just stuff the rest into that hole over there. And then it should be coming from here in the cleanest way possible. There's still more cabling to come, so that's that, and even more, and more, and more. Okay, done. And this, which is meant for I know, I will worry about it later. This is a cable that goes to I don't know about this one, but I know this one. It goes into motherboard USB 3 connector. It is done. Then USB and HD audio. Then one thing I also have is a front panel extender. I bought this from AliExpress at some point, so let's see if I can also use this one somehow. So it should be going here. Okay, this turns out to be an awkward challenge because this extender here it's quite short form. So when I push it inside here and the screws align here, over here, there's nothing here holding it place. And the clip that is supposed to go here and which is supposed to affix that thing in place, it just doesn't hit anything, because if I put this here, see what happens. Actually, there's supposed to be a spring here also, so let's put that spring in. Spring is in, and put this in place like so, and I push this in here, assuming the thing is in proper position like that, and this goes in. This means nothing, and it doesn't lock this in place. This doesn't actually work, so I would actually have to need a bracket that pushes this way instead of this way. So it would have to keep the connection like this. So I fixed this by inserting a screw here that pushes this end in, and now this is in place. Not securely, but it will have to do. There is also a screw hole on this side, so I might probably should also use that screw. So reset switch is over there. Then HDD LED plus and minus are over there. Then power switch is over here, and there's no HDD LED connector, I believe. Alright. Then power supply installation. This is already kind of awkward here, but let's see. And the fan should be pointing upwards because it's going to suck air from inside this thing. I think it's going to suck air. That's what I remember it doing. And be careful to put the screws in the screw holes and not the fan holes, because that is a mistake I have done before, trying to put the screws in the fan holes. Okay, that is nice and secure. Then to see what to do with this massive heap of cables. This is a modular supply, so I don't actually need to have this kind of heap here, but I already know that I am going to need each and every one of these cables, because I just moved this setup from one computer to the next, so I already know what I'm going to need. Or actually from one PC case to the other. So I know what I'm going to need. And it is so hard to make sure that everything is constantly in focus and the camera is pointed the right way, and I'm working where you can see me. Well, you cannot really see me, so that is already a lost case, but I'm sure you get the big picture of what I'm trying to tell you. There's a lot that goes into making a video that is not very apparent when you don't have experience with what are the things that it involves. And it's connected. Then a CPU cable, CPU power cable goes from this hole Another CPU power cable. Next thing, let's populate the hard drive slots. So I think I'm going to need to take each one of these out first, and then insert the drive into the socket, push it in, and probably not slam them as hard as I just did. So each one of them inside there. Do you please go peacefully? It's not going peacefully. Ah. Oh yeah, these drives are different. Yeah, this has 3 screw holes, but this has only 2 here. Wow, that is so weird. So let's put this one first, which is easier to put in. And then next one, this one, also should be going relatively peacefully, because it also has 3 screw holes here. So I should be able to get it inside there. Go in. Oh yeah, there we go. Western Digital. Pain, 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 pain. Do I just like hope it stays there? Because that is really awkward. I don't know why this is not having the proper screw holes there. Because when it is lacking those, I simply cannot push this in. And these are all the same, right? Yeah, they are all the same. This one has those 2, and this one has those 2, and this one has those 2. So that is actually not the only problem. There is not the only problem that there should be these 2 screw holes here, but there's only 1. There's also in the bottom there's 2 tabs that should be matching with screw holes in the bottom, and there's just not those screw holes. If you compare with this Western Digital drive, if you can see from that video, you can see there's a screw hole there and there's a screw hole over there as well, but not in this Seagate drive. So this is proving to be a dilemma. I have 2 of these Seagate drives that are misbehaving because I cannot attach them like they are supposed to be attached. There is of course the option that I could just clip away these things and basically brutalize this thing, but that is not a very nice and clean solution for these misbehaving illegal drives. And of course I don't mean illegal literally, I mean figuratively, because they do not match the expectations. Well, this is awful, but I think what I have to do is just clip out this center stud here. Like so, so that I can put this drive in there. So it is now fixed in place with 1 screw there, one little stud there, and then I just use screws to affix this into the holder. So one side there and the other side here. So not exactly toolless, Also should probably have a screw here to reduce vibration, but let's see. Yeah, I should probably put that one screw there. So which side? Probably here. Yeah, that should be enough. So it's now there. And the same procedure into this one. Clip and take these sidebar things away. Okay, there we go. And then put this archive drive here. It's there. And then the same as 3 screws. I'm using a lot more screws in this project than I thought I would. There we go. So an HDD there. But I'm not done with the drives. There's also this SATA, this SSD drive. So let's also do that. And the SSD drives go on these 2 sockets here. And I should probably, the connectors are on this side, so I should probably put it like this, so it's easier to cable than if I were to do it some other way. There is also CD/DVD drive, which I am going to insert into, let's put it the right way, this slot right here. The fan, the cooling cables are kind of out on the way, so I have to put it like this. And it's there. Not very securely, but I suppose that's okay. It's not very good. Yeah, I probably should have put this the other way around, because now these water cables are on the way, and that's not very good. Remove these screws and turn the CPU cooler the other way around. So let's take this . Like this instead. I was hoping these water cables would not be so much in the way, but I guess I have to do what I have to do. So the horizontal position of this can be adjusted, and I should probably have it like this so that I can still access these memory sticks. That is so inconvenient. Well, the cooler is taking so much space from there that it's not really possible to use the top slot. So use the one that is below it, like I was going to use. But this is really not very secure, so I have to use a screw to hold it in place. Now it is secure. At least it is secure enough. Then there are a few more things. There's a graphics card which has to be inserted there, and it goes into this slot, so I will have to remove this little cover there and insert the graphics card. In the PCI slot is alright. So now I have just have to affix this back in, and it's best to use these screws that were already there, because that way I won't lose them. Then the display card will need a power. It's this connector, but to make it pretty, I will of course do it in the back behind. Over there, and then insert it from here so that everything is pretty. And I will use this one which is closer, so there's tiny microscopic little bit less of resistance. Not that it really matters, but it's the comfort of mind. And it's connected. I'll still probably have to put something that holds this up, because that hanging thing is not very nice. And then we have a heap of power cables. I have 2 slots here for the SATA, and this is Molex, and I will probably need a heap of more. It's not exactly a heap, but I do have this kind of extender which converts 1 SATA slot into 4 SATA slots. So let's see, 1, 2. I have no use for this one. How am I going to make everything work? I also have a, with the power supply came another one of these hard drive power connectors, but this is the old style. It's not the SATA. Here's one which can convert an Molex connector into this one. Okay, I was concerned for a moment, but when I looked into my storage, I found another SATA cable which came with this motherboard power supply, so there is actually no reason for concern. Then I'm going to need a heap of SATA cables. Oh, by the way, there was one more cable that I had kind of misplaced it, so that's why I didn't find it. Next, the motherboard already has 8 connectors for SATA drives, but I am also going to add this little card, which adds 2 more here and 2 more on the outside. Actually, on the outside I think it's a different type. It's an SATA drive, but I will use these 2 which are normal SATA drive. Screw, take the shield out, put the card in. Alright, and now let's do some cabling. So the SSD drive is the first one to get the cable, and the cable goes through here, and the drive goes that is kind of awkward. Can I use a straight cable instead of this angled one? Angled. Yeah, this. A straight cable instead, so let's put it here. The cable goes over there. And the drive goes over here. And the cable goes again here. And that should be enough for now. And then the cable is too short. The cable is too short to be connected that way, so instead of pulling it all the way over there, I will just push it through, say like here. And now I see this is really meant to be connected another way around. Well, too late to cry about that. So, okay, let's say it's not too late. This is kinda inconvenient. Not what the manufacturer was probably planning. And it's there. Hopefully that is solid enough. These two cables should be going to this card here. This is the most unbeautiful connection I'm going to make here, and actually they are not even going to stretch far enough. So that's a no-go. No-go there. It's just a little bit too short. So these are not going to be connected anywhere. Too bad. Okay. So I wonder, am I still forgetting something? I have the cooler connected, cooler cable is connected. All the powers are connected where they should be. The display card is connected. The drives are connected. So next I need to put this top panel back on and then the front panel back on. Probably in the opposite order though. And that's pretty much all. So the front panel, actually I was supposed to put the top first. So the top panel goes on top of this, like so. And now the people who complained about my table microphone are going to feel like idiots. And let's put this on the front then. Actually I need to remove these first to make openings for the things that are in the front now. So these two have to be opened and then I can put this in here. There we go. Excellent. And on the top let's put the little dust filter. That is already very dusty. Let's see. So put this in here and this in here. And then the back panel, which looks like this, needs to be closed as well. What did I drop? Nothing important. I didn't drop anything important. So the back panel, which is here, has to be put there as well. So let's see. I still have to find a organizer place for this cable. By the way, if you are wondering why do I look over there once in a while, it's because I'm using a camera that is a photo camera, not a film camera, and because of taxation reasons the film camera makers make it so that the camera stops recording automatically after a while, just so that they don't get classified as video cameras. So in order to evade stupid taxation rules, they do stupid things. Okay, these don't seem like they are going to fit very nicely. I will sort that out later. So get the stuff out of the way. This one too. Okay, it's time to test whether this run. And to test it, I have here a PS2 keyboard. Actually, it's an IBM AT keyboard, but I have an adapter here which converts it into a PS2 keyboard because, listen to it, it's a mechanical keyboard and people like mechanical keyboards, even though I digress, but people like them, so let's just put it in, connect there, and then power this thing on and see what happens. Power on. Power on. And power off. It went off also. I don't know why it does that. Why it does that? There's a LED display over there. Am I even in the focus, by the way? Yeah, I guess I'm enough in the focus, so... Is it or not? I guess that's fine. So anyway, F2 or del to run setup, so let's do that. It says 49 over there. I don't remember what that means. 49. In the little LED display there, that is probably too small to see on the camera. Maybe I should zoom a little bit. So, can you see it? Well, it says 49. F2 or del to run setup. Nothing is happening. Let's just wait for a while. And it doesn't even react to caps lock or num lock or anything, so that's kind of disconcerting. Did I do something wrong? $49. Now, to be honest, I didn't really check whether the memory sticks were pushed all the way in. Oh, it says 50. Oh yeah, that's actually a temperature. Okay, so that is the that controller that gave me the extra SATA ports. So it's actually progressing. Now it's not just blinking the cursor. And what's happening next? It's in the grub prompt. And it's still not reacting to my keyboard input. The temperature is going up. That is actually not the real temperature. That is the estimated offset temperature. To get the real temperature, you have to subtract 27 from it. And now I got a kernel panic, so something is definitely up. It says kernel panic in modulus link. Okay, so because I cannot scroll this up, I don't know where it happened. But in any case, the first problem here is that the keyboard doesn't work. So I guess I will not be using this funny little keyboard. So I will use a different keyboard. This is still a PS2 keyboard. This is the keyboard that I use normally. So let's see, I have to reset this. So yeah, that 49 was actually temperature reading, and if you subtract 27 from it, you get 49, you get 22 degrees Celsius, which is about the room temperature here. Okay, so F2 or del. And this keyboard is actually working. You probably cannot see. Yeah, you can actually see. It is actually reacting to these lock buttons. So this keyboard is working, and it's a PS2 connector keyboard. So let's go to BIOS and see what is wrong. Okay, so it's telling me here I have 16 gigabytes of memory, and the processor speed is something. Let's reset everything. At least let's put that in auto, and let's put memory in auto, everything auto. Actually, if I just load default settings, that should be fine. So let's see. one of the first things I should probably do is set my fans. Let's see what happens if I use this fan tuning. Detecting your fan speed. And this goes on for a while. Now, in my fan configuration over there, it is entirely possible that I have my fans connected the wrong way around. I mean, for example, that all of these fans are sucking air out from this enclosure and nothing is pushing it in. That is entirely possible, and I will have to sort that out. I have not forgot about it. It is entirely possible, and I have to check these 3 fans over there. At least I know this power thing is sucking air out, so it is pushing air out. But and this fan over here from the case actually also seems to be pushing air out, and I don't know about those. So I will have to check those. Alright. So it has set some settings here. Let's see how do these work. So for CPU 1, fan 1, CPU optional fan is actually the water pump, so CPU opt, that should be the water pump. And the normal temperature should be, yeah. So the first step, 22 is like my room temperature, so it shows us. So it could be like that, and then crank it up really soon, and full speed at, say, this should be 79 says about 52. So when the real temperature is 52, then it's full speed and like that. So let's do the memory first. It should be at 3 gigahertz. So let's do that and verify that the memory actually works. Save configuration settings and exit. So the settings that I have now selected are so that CPU is not overclocked at all, and memory is technically not overclocked at all, although it's running at 3 gigahertz, which is what it is specified for, so that should be okay. Now let's run mem test. Mem test is running. And actually in my tests, this is taking quite a long time, and I have found that if there is a failure, it happens in test number 7. So I'm only going to run test number 7 from now on. So it's test number 7 block move. And like I said earlier, the memory sticks are now in slots B2, D2, C2 and A2. So those are where the memory sticks are as they are supposed to be. Also, I should probably move this SATA card that I put right next to the display card. I should probably move it way down here, because right now it is actually blocking one of the fans of this graphics card, and that was not the smartest idea that I have had. Okay, this memory testing is taking quite a while, and if there were problems, they probably would have shown by now. So I'm going to do something interesting next. Let's power this computer off first. And then next I'm going to install more memory, because more memory usually makes things better. And I am now not actually just playing around here. I do actually, from time to time, I do run applications that really do require that much memory. Usually they are programs that I have made on my own, which are running some kind of optimization problems, but I do still run out of memory once in a while, while doing that kind of tasks, so that's why I'm installing more memory. HyperX. These are nice and cold memory sticks. They're not going to be cold for long. The BIOS says that I have here, let's see, RAM information. It says that I have this type, it's 16 gigabytes, and it's manufactured in week 41 in this year. So slot 1, slot 3, slot 5 and slot 7 all have the same specifications. Nothing changed when I switched to between these different slots. And then slots 2, they have a different week. Everything else is exactly identical as the before. Slot 1, slot 2, everything else is identical, but the week changed. These are older sticks. These are from week 15 this year. So slot 2, slot 4, slot 6 and slot 8. So these are paired properly. Unfortunately I was unable to get all of the 8 sticks from the same week. That just happens. So these are all configured according to the XMP specifications. Front panel, HD, deep sleep, on Bluetooth, onboard debug LED. Here we go, runtime TPU temp. I won't change anything else, let's just try that. Alright, let's run memtest again. Starting the test, and let's run the test number 7 again. And look at that! We got an actual error in test number 7. And that's why I like to run test number 7 first, because it is the fastest one to bring forth memory errors. And there's a problem with this setup. The memory sticks are 3 GHz as I told before, and when I have 4 of them they work just fine. I can even overclock them into 3.1 GHz and it still runs just fine. The memory test goes through without any problems. But when I have 8 of them and paired just as the manufacturer recommends me to pair them, then I get these errors and I cannot actually run them at 3 GHz, so I will have to use something a bit lower. Let's try 2.9 first. Let's try that. It is kinda shameful that I have 3 GHz memory here and I cannot run it at 3 GHz. If I have just 4 sticks it runs fine, but when I have 8 of them it doesn't run fine. And that's bad. And we are running test number 7 again with memory overclocked at, not overclocked, but specified at 2.9 GHz. And at this point I want to apologize, and I want to apologize because for the past who knows how long I had a crappy audio here because I forgot to start recording on the computer that runs Audacity, and so therefore the microphone that is next to me was not connected anywhere, and I had to, in the post process, I had to rely on the audio from this camera that you can probably see in the reflection over there. This camera, yeah, you can just barely see in the reflection. So I had to rely on that audio, but now this audio is coming from the microphone, which unfortunately is coming closer. It's very close to the power fan in the computer, so there's some humming there, which is unfortunate, but at least the sound quality in terms of my voice should be a little bit better. So let's run this test number 7 for a while and see if there's a problem. In the meantime, while it is running this test, I will do some tests also to measure whether the air is being, which direction the air is going. And one of the best ways to check which way the air is going inside is to use a little bit of paper and see where it goes. So, for example, this seems to be getting sucked towards the paper, and also at the same time we got some errors in the mem test, so also this frequency is not good. So there's one fan here in the front which is pushing air into, and this is sucking out. It goes out from here, it goes out from there, and this one also, hard to tell, but I think it's also sucking air out. So anyway, we got errors in this mem test, so I have to use a lower frequency even now. It's taking its sweet time. And the reason why it's taking so long to boot here is because I know one of these hard drives is kind of broken, maybe two of them. So that's the reason. So for the memory, one step lower, and also probably I should now set the CPU overclocking, because I kind of want to get into that now. So let's try. This should be probably fine. 4.075 gigahertz, and memory is 2.866. That should probably be fine. NBIO, fan control, CTPP, yes, this one, watts, so 450 watts. DRAM voltage could be fine. I'm not going to set that. But these levels here, I'm going to change them. This is going to be like that. Hopefully those are fine, maybe level 3. And let's boot up the Linux and see what happens. Does it still crash and boot? Loading Linux. Oh yes, we are still getting a kernel panic here. It may be because of this SATA extender, so I'll have to take it off and see what happens next. And now let's try again, this time without this card. And it seems to be booting up. So it probably was this one. I also disconnected 2 drives that are kind of broken, so next thing of course would be, what everyone would like to know is how fast is this computer actually. So let's do some benchmarking. I have the parallel thing here, Mandelbrot Vanilla, Mandelbrot this one. Here's how it works. This is on the old computer, the performance. It's my baseline with 8 threads. This is the same with SIMD enabled. Sometimes SIMD made it slower, but sometimes it made it faster. And this is on the new computer with 32 threads. This is on the new computer with 32 threads and SIMD. Interestingly, it was quite a bit slower here, but sometimes faster. This was the same without AVX2. It was actually faster in many parts, and this is with CUDA. It is interesting that this 16-core 32-thread processor was actually faster than the CUDA version. Let's see that again. So the CUDA version was kind of neck to neck with the fastest possible Haswell version for the old computer, but for the new computer it didn't beat it at any single point, which is kind of interesting. The graphics card that I'm using here is a GTX 970. Here in this window you can see in real time the computer temperature, there is the die temperature, and there's the control temperature, which is the one with a plus 27 offset. So these are basically the same thing, but this is always 27 degrees higher than the other one. And that's the CPU temperature. It is also duplicated here, and it is also duplicated here. Sometimes they don't match exactly because of, I don't actually know why. This is probably the motherboard temperature, I'm not exactly sure. So the first thing I'm going to do is run the benchmark of the POV-Ray using a screen called Abyss, with a width of 2048 pixels and height of 768 pixels, with some pretty high anti-aliasing settings. So let's see how that works. Actually, I think I saw better temperature earlier. It's doing it on just one core for some reason. Oh yeah, I have to enable threads, so let's do 32 threads. Here we go. Ah, that's so much better. The temperature, CPU temperature is climbing, it's 76 degrees, 77 degrees now, and that's done. Then there's another thing, there's POV-Ray has an official benchmark. It renders this kind of scene. On the benchmark page they provide official settings for testing it with. So let's run that also. And I'm also going to enable rendering for this one. So it's going to create a small window, 512 by 512, but let's see how it works. Here we go. It's a tiny window there. The CPU temperatures are much higher now, it's 85 degrees now. POV-Ray version 3.7. Yeah, it's sticking quite steadily at 86 degrees. It's a little bit higher than what is recommended for this CPU, but it's still not terrible. And the render time was the total time was, actually I should probably do that again with times, so let's do that again. And there we go, and that took 35 seconds total, 30.496, and the POV-Ray version that I'm using is it's a Debian unofficial build. It's an unofficial Debian build for POV-Ray version 3.7. So some people asked me, why do I use this Ryzen 1950X when the 2950X is also available, and it also has 16 cores, but it is faster and uses less power or something like that. And the reason is, when I bought this processor down here, the 90X 2950X was not yet available. It was released 1 month later, so that's why I have this 1950X. In any case, this is my computer now, so this is what I am using to make these videos. This very video was encoded on this computer, although at this moment when I'm speaking it hasn't yet been made because it's still being recorded. But when you are watching this, it has obviously already been made and published and so on. So let's take a final look inside this case. So this is the back side of the computer. It doesn't look very nice right now. I still have to figure out how to flatten all these cables. That's some labor to do, but at least the presentation side looks pretty nice. If I still open this one more time. And there we have it. Can I zoom? Yeah, I can zoom. So yeah, that is pretty much what it has. Can I focus? Yeah, I can focus. So that is pretty much all there is. I probably will put a little wire here to push that card a little bit up so it doesn't weigh so much on the PCIe socket. And I will also have to figure out how to install a beeper in this computer, because I want a PC speaker. So that's also something I have to do. But other than that, I think this project is pretty much done now, and I can start using this computer normally. So thank you for watching. See you next time. Bye.